I hope you all had a lovely, lovely weekend. And you got to sleep in and you got to play. I hope you guys had fun with your science homework. Hop over to here first. I have already given everybody who did their homework 1 point on Class Dojo. So you guys can take a look at your points right now. If you did your science homework, you have 1 more point already. So thank you everybody who did your homework. Okay, I already put it in here. Well, let's get started. Everyone who did their homework has a point on Class Dojo now. Okay, let's begin. Science with Miss Miranda. Here we have our gas that fills its container. Liquid that takes the shape of its container. And our solid. Puppy. Puppy, can you read that today we will?
Today we will review solid, liquid, gas, volume, and mass.
Excellent. Next one. So first we'll do a little review. Next, how about Jack? Can you read number 2?
Here, the homework videos.
Very good. So after that, we'll share homework videos. And number 3. Number 3, let's hear it from Bunny. Starting with today. Can you read number 3?
Today we will use things in your house to talk about properties.
Excellent. Very good. Nice reading, Bunny. Okay, so the first part was the review. Remember, we took a look at this yesterday, and now that you've done your homework, maybe it'll be a bit easier. How many milliliters is this water on the left? Moon?
17
17 what?
millimeter.
Milliliters. Very good. Okay. How many milliliters of liquid and solid together are on the right? How many milliliters are over here on the right? Taylor?
There are 17 milliliter, and the gold is 3 more, and then it is 20 milliliter.
Excellent. So exactly, that means that this gold here must be 3 milliliters. It added 3 milliliters of volume. Very nice, Taylor. So that's how we can find out the volume of a solid. All right, everyone, let's see if we can do this as a class. Number 1. Everyone read number 1. Who thinks they can tell us the correct answer? Who thinks they know? Let's start with Zook. Go ahead, Zook, with number 1.
Everything that takes up space and has mass is called matter.
Excellent. Perfect. Okay. Number 2. Number 2, raise your hand using the button on Zoom. Sophia, go ahead.
The amount of matter in something is called mass.
Nice. Excellent work. Okay. The amount of matter is mass. Number 3. Number 3, Ray, go ahead with number 3.
A matter cannot always be seen. It spreads as you feel the space. It is called a gas.
Excellent work, Ray. Nice job. Okay, next one. Let's have hands up. Raise your hand using Zoom if you know. Susu, go ahead, Susu.
Matter that has a shape of its own is called solid.
Excellent. Very good. All right, number 5. Pasta, number 5.
Matter that flows and takes the shape of their container. It is liquid.
Very nice. Okay. And the last one. Who knows the last one? Let's hear from Taylor.
The bottle on the right can hold a larger volume of water than the bottle on the left.
Excellent. Very good. Remember, volume's how much space it takes up, so we can put a larger volume of liquid on the right. Okay, solids. Read just the underlined words, okay? Everyone read just the underlined words. So there's 4, 1, 2, 3, 4. 4 things that are underlined. Let's just read those, okay? All right, everybody, go ahead and unmute and read solids.
Their own shape.
Keep their own shape.
Very good. And what does fixed mean? What does fixed mean? Who can tell me what fixed means? Banana, do you remember fixed? What fixed means? Anyone else? Sam, what does fixed mean?
It means stay the same.
Stay the same, exactly. If I move a solid, it still stays the same mass, so it still has the same amount of matter, and it stays the same volume. It still takes up the same amount of space. So it's fixed. It stays the same. Everyone go ahead and say that. Fixed, stays the same.
Fixed.
Fixed.
Stay the same.
Very good. Okay, so solids keep their own shape unless it's broken, cooked, twisted. They have a fixed volume, so you can measure it using water and a measuring cup, just like our piece of gold, and they have a fixed mass. You can measure it using a scale or compare it, 1 minute, to another object using a balance. So we measure using a scale or compare it using a balance. Okay, what is your question? Go ahead.
What is tensed?
Twisted, this word here, twisting is when you turn something the 2 opposite directions like this. So I can twist. Okay, next one, again, please read the 4 underlined parts, starting with liquids. 1, 2, 3, go. All right, liquids do not have their own shape. This is the only way they're different from solids, because this one and this one are the same as solids. Solids and liquids share these, have them in common. This is the way that liquids are different from solids. Just one difference, okay? But they do still have a fixed volume. You can measure it in a measuring cup. Moving the liquid to another container will not change its volume. There's still the same amount. I think some of you guys saw that when you did your projects over the weekend. And liquids have a fixed mass. You can measure it on a scale. Okay. Last one, you all know what's next? Gases. Okay, go ahead and read these 4 things. 1, 2, 3.
Gases do not have their own fixed volume, fixed mass.
Do not have their own shape. They move in their container all the way out. Gases do not have their own shape. They will fill their container all the way out. 25 minutes and 15 minutes.
Okay, very nice. Okay, so they do not have their own shape, just like a liquid, but this is the way. This one is the way they are different from liquids. They don't have a fixed volume. The same amount of gas, the same mass of gas could fill 25 milliliters or 50 milliliter bottle, okay? Because it spreads to fill its container. It can get spread and smaller. Okay, share your homework. We have time to look at 3. So,
Don't take mine.
we are going to watch Moons tomorrow because Moon, you actually talk about something new we're learning tomorrow called solubility, which is when a solid can mix with water and disappear. All right, so we're gonna watch Moon's video tomorrow. So I would like to watch Sam's video
Me.
and Susie's video. Is there one more person that wants their video shared? Who would like to
Me.
see?
Me.
I see Ray's hand and Taylor's hand.
Taylor.
Okay, we'll do Ray or Taylor. Ray, I'll try and find your video, okay? Please listen nicely to your friend's video, okay? They put a lot of work into it. So let's listen nicely to your friend's video. Let's start with Sam's.
Hello everyone, my name is Sam. Today I will make apple juice. First, the materials is apples, 3 apples, and the scale, the plastic bag, the knife, and last is the machine that squeezes the apple into the liquid. First, I will use this scale and the plastic bag and 3 apples. I'm right. It is how many kilograms? Okay. Now let's start it. It is 54 kilograms. It is 54 kilograms, and then we'll use this knife to cut the apples. 50 kilograms, and when I put it into this machine, you can see 54 kilograms is how much milliliters. Now, the dangerous part is chop. Those will like 2 of these, and then we'll cut the middle, so they got 4 small pieces.
I'll skip through a little bit of the cutting and things like that, a little bit of the waiting time, so we can hear your talking.
See that this machine is squeezing this apples.
Squeezing, very good.
Squeeze the water over here. And the shell here. The juice will be in this. And the this 54 kilograms, it's equal to 350 milliliters.
Very nice. Great
Now I'll
comparison.
pour it. It just changed color from red to yellow.
So now Sam's talking about some of the properties, what he can see, what he can smell.
Brown mixed with jello. And its smell was sweet. Its taste was very tasty. I like apple juice. And wait for it to pour all this out. Okay, this. Okay, now it's time to me to pull it to the cup. You see, at first it was solid, and then this squeeze it into liquid. A liquid don't keep its shape of its container. It's from a big cup, and then it takes the shape of the big cup and the small cup.
Very good. So he's saying it changes shape when he moves it from the big cup to the small cup. So it's a liquid, not a solid.
And even solid, you can break it, but it is hard to break because it can be very thick. And then I will drink this. This is yummy apple juice.
All right, excellent work, Sam. Very, very good. Nice job talking about the different properties of solids and liquids, including smell. He talked about hardness of his apples, how they were hard to cut. He talked about color. All right, nice work. Let's take a look at Susu.
A drink with liquid. Hello, I'm Susu. Today I'll make a drink with liquid gases, solid. This is Coke. It has liquid, which is the water inside, and the gases are the bubbles.
Nice job
This
talking about the
is
gases as
ice.
well.
It is solid. This is the watermelon. It is also solid. This is the juice. It is a liquid. This is the measuring cup. This is the scale. We pour the Coke into here.
Oh, it's gas. How many? 1, 2.
This is the gases inside the Coke. We put the watermelon in here. Next, we put it inside here.
Many gas.
Then, next we pour
What is this?
ice inside.
Yes, gas. So many.
Freezing cold.
Wow. Yes.
Temperature is a very
What
good
is this?
property to talk
This
about.
is juice.
How many you want to? So, how many?
80, I think.
Yes.
Okay, 80 milliliters.
We have made a drink with solid, which is the ice and the watermelon. Liquid, which is the juice and the Coke, and gassy, which is the bubbles inside the Coke. best thing of all, it's yummy. Bye-bye.
Thank you, Susu.
Nice work, Susu. Excellent job. Talk about solids, liquids, and gases. Susu used all three, which is the reason, one of the reasons I picked Susu's video. Sophia, do you have a question?
I can't hear you.
You can't hear me very well. I know it's a bit quiet because it's playing on my computer. Could you hear a little bit? Yeah? Okay. All right, our last one we're gonna watch today will be rays, but we're gonna watch 3 more tomorrow, moons and 2 more. All right, sadly we don't have time to watch all of them, but that's why I gave everyone a point on Class Dojo. Ray, I need to add your point because you guys really did a really, really good job. Ray has 2 videos. That one was weighing, and I think this one is his submarine. So let's take a look at this one.
Hello, I'm Ray. Today I'm going to measure the volume of the egg, the apple, the milk.
This one's different. So Ray, this is your measuring, which is this one the submarine? Ah, here's the submarine. Okay.
Hello, I'm Ray. Today I'm going to talk about my submarine. It is made of spoons, a tube, a bottle, a balloon, and some ribbons. When the air in it, it floats. It floats up.
Whoa, that's so cool. That's such a good idea, Ray.
When we leave it alone, it sinks down. When we leave it alone, it sinks down.
我们kéo mưa giữa này thì thấy nó xinh chứ.
All right, actually, you guys have some homework tonight trying to find things that float or sink, which is why I was glad Ray did post a video of it. So, float is when it's on top of the water, and sink is when it is heavier than the water and goes under the water. Banana, what does float mean? Banana, what does float mean?
I cannot hear you.
Okay, what does float mean? Float. It was just in Ray's experiment, the submarine floats and the submarine sinks. What does float mean? Can look back here. See here, Banana? The balloon is filling up with air. Okay, and we can see when the balloon fills up with air, it floats up. Banana, so what does float mean, Banana? What's the water bottle doing? All right, let's see if someone can help Banana. Sino, what does float mean?
Float mean is like something that go up the water and will not sink.
Excellent. It stays on top of the water. It doesn't sink. So, Sino, what does sink mean?
Sink means it's stay under the water.
Excellent.
Not float.
Very good. Ray, this was perfect, everyone. Any questions about floating or sinking? Because this will be part of your homework tonight. Pasta, is that a question or is it you saying you want to watch your video? Question?
We have to find anything that floats or sinks and compare them.
Yep, that's going to be your homework tonight. I'll explain more when we get to that slide, but yes. So again, any questions about float and sink? Okay. Very nice job, Ray. Ray also did some of the measuring ones, but we don't have time to watch any more. But I'm sure that they were very good. I saw a scale. I see you testing some volume. Maybe I'll skip forward a bit.
Hello, everyone. At the pickleball, liquid, solid, or gas? I put it 300 milliliters into the measuring cup. The egg is 50. The egg is 50 milliliters.
All right, so now the water went from 300 to 350. So Ray knows the egg is 50 milliliters. All right, and I see here, these are the other projects you guys worked on. Again, we don't have time to watch every video. All right, we've got a mix of the projects you worked on. This is Jack weighing his sister. You guys had some really good ones. Blue Moon also made juice. He did a really good job making the juice. Maybe we'll get to watch some more of these tomorrow. So, shape. What is the shape of gas? Can anyone tell me what something that is gas shaped? How about Zook? Zook, what's the shape of gas?
Gas don't have shapes.
There we go. It was a trick question. I tricked you. Gas doesn't have any shape. Good job, Zook. There's no shape. What about volume? How much space does a gas take up? How much space does this gas take up? Can you tell, Sino?
The gas takes up no space.
Good. Well, it does take up space, but it changes. If we moved all the gas in this balloon to a bigger balloon, it would still fill up the bigger balloon. The volume would change. Nice work, Sino. And mass, we do know it would still be the same amount of matter, even if we moved it to a new balloon. Does anyone have something around them with a gas? Anyone have a gas around them that they could tell me about? Rosie, can you tell me something that is a gas? Rosie?
Because air was invisible, it has no volume and it has mass too.
Excellent. It has mass. It has no volume. Very, very good. All right. And who can tell me actually, Rosie already said the properties of gases. Nice job, Rosie. That was great. All right, so Rosie just did it at home. Very good. What about a liquid? What is the shape of a liquid? What's the shape of a liquid? Cherry, go ahead.
The shape of liquid is the shape of something.
Excellent. Excellent job, Cherry. Exactly. Does the volume of a liquid change when you move it to a new cup? Milk, what do you think? Does the volume, the amount, the volume of liquid change when you move it to a new cup? Let's say I pour this milk into a bigger cup. Does the volume of the milk change?
No.
No. Can you say a full sentence, please, Milk?
When the milk pours into another cup, it does not change.
Excellent. Very good job, Milk. The volume and the mass, how much matter there is, does not change. Now you try at home. Who has a liquid next to them and can answer these questions for me? Let's see. Who haven't we heard from a lot today? Bunny, do you have a liquid near you?
Yes.
All right, Bunny. How can you tell that you have a liquid next to you? How do you know it's a liquid?
Because when I pour it to another container, it takes the shape of this container.
Excellent. Do solids do that, Bunny?
No.
No. Nice work. Okay. So who can tell me some properties of liquids? Jack, what are some of the properties of the liquid next to you?
The properties of the liquid near me is it will help us to wash the hair fast.
Excellent. Can you talk about maybe color, smell?
Color, the glass color.
Okay, so it's clear. We say clear, no color. What about smell? Does it have a smell?
It is yummy.
Yummy. And is it thick like ketchup or is it thin like water?
Thin.
Thin. Okay, so it's not very viscous. I know we've heard that word only once or twice. It's thin, not viscous. All right, and the last one, here is a solid. Are solids always hard? Sophia, what do you think? Can you answer in a full sentence?
No.
Full sentence. Oh, I think I'm having some connection problems. I couldn't hear Sophia. That's okay though. Can someone give me some examples of solids that are soft? Because remember, hardness is a property. Misha, can you give me an example of a solid that is soft?
I think it's teddy bear.
Yeah, teddy bear. Anything else?
My pencil case.
Okay, yeah. Maybe the clothes you're wearing. These feel pretty soft to me.
Yeah.
You know you have one?
It's a pillow and a blanket.
Yes, those are great examples, Sino. Very good. So, shape. It keeps its shape. It keeps its volume. It still takes up the same amount of space. And it keeps its mass. Let's just answer this last question. What are properties of solids? I want to know, what can you look for in a solid? Who can list some properties we can look for solids? Zook, give me one.
They don't change their shapes.
They don't change shape. Very good. Who can give me another property we can look for? Pasta.
They have their own shape.
That's what Zook said as well. But I mean, I'll do an example. One property I can look for is the color. Can someone give me another one? Rosie? Taylor? Rosie and Taylor.
Hardness.
Okay, Taylor says hardness. Rosie, can you say another one?
Texture.
Texture. So we have hardness, texture, color. Maybe we add flexibility, smell. Okay, today we learned how to talk about properties using things in our houses. Homework, sink or float, just like Ray's submarine. Find 3 objects and test them in water. Do they sink or float? Please take a picture of each and send it in. So you should send in 3 pictures, okay? And this could be anything, solids, liquids, okay? Does it sink in water or does it float? You can draw, write, or take a picture. I leave it up to you. Draw, write, or take a picture, but I need proof. I need evidence that you did your homework.